My presentation is about the preparation of 2-cyclopen-2-enone derivatives via the as a Pencatelli rearrangement. For this reaction, we're going to be using the furan 2-carbaldehyde, which is also known as furfural. The molecular weight for it is 96.09. And then we're going to use phenyl magnesium bromide, which molecule weight is 181.32. Mix it with THF, and our final product is going to be furan 2-ill-phenyl methanol with a molecular weight of 174.20. The apparatus description, as we can see in the picture, it's very simple. It's an oven, a dried 500 ml 3-necked round-bottomed flask equipped with an egg-shaped Teflon-coated magnetic stir bar is capped on all necks with rubber septa. Phenyl magnesium bromide is charged into the flask under an atmosphere of nitrogen at 5 degrees Celsius, and the internal temperature is always below 25 degrees Celsius. The main reagents used in this reaction is phenyl magnesium bromide, 57.4 ml of it, which is 57.4 millimoles and 1.0 equivalent and 1 molar in THF. The second one is for furfural, which is 4.76 ml with 57.4 millimolars and again 1.0 equivalents. We have also used 70% of hexanes and ethyl acetate as diluent, p-anisaldehyde for staining, magnesium sulfate for drying, and ammonium chloride for extraction. The procedure for the whole reaction was that 57.4 ml of phenyl magnesium bromide is added to an oven-dried 500 ml 3-necked round-bottomed flask. It is charged into the flask under the temperature of 5 degrees Celsius, which is kind of like an ice water bath. And then 4.76 ml of furfural is added over the course of 30 minutes via syringe into the cold reaction through a side neck while making sure that the internal temperature is always below 25 degrees Celsius. Once all the furfural is added, the reaction stirs for 4 hours. The reaction is monitored by thin layer chromatography analysis on silica gel with 70% hexanes and ethyl acetate as eluent and observed under 254 nanometers UV light. The reaction is then stained with p-anisaldehyde. It stains it a dark blue-brown color with a RF value of 0.46. Reaction workup. After the TLC analysis is done and the reaction is stained with p-anisaldehyde, the reaction is then quenched with saturated aqueous ammonium chloride. It is then transferred into a 1 liter separatory funnel and extracted with ethyl acetate. The combined organic layers are then dried over magnesium sulfate. It is filtered and concentrated to produce a yellow-orange oil. The product of the crude reaction mixture is purified via column chromatography. The last step of this reaction is the purification. The product was purified using column chromatography with a gradient of hexanes, which is ethyl acetate from 100% hexane, to a 3:2 ratio of eluent. To a column, 165 grams of silica was added and prepared with a 9:1 eluent solution. The unpurified product was then dry loaded onto cellite and loaded on the column. The product was eluted with 500 ml of 100% hexane eluent, followed by 750 ml of 4 to 1 eluent, and lastly 500 ml of 3 to 2 eluent. The fraction containing the product were identified by TLC and then were combined. The solvent was removed by the rotary evaporation of 25 degrees, and the final percent that was yielded was 9.71 grams, which is also 94%. A little about the authors. The first author that we had was Megan F. Nicole. She earned her BS degree in chemical physics from Lewis University in 2015, where she conducted undergraduate research under the direction of Dr. Jason J. Keller. Megan then moved to Santa Barbara, where she is pursuing work in self-immolative polymer trigger systems. Our second author was Louis Limon. He is an undergraduate researcher at the University of California at Santa Barbara, pursuing his BS degree in chemistry. He joined the Read the Alanis group in the summer of 2016 and is currently working on development of new methodology for small molecule synthesis. Then we have Javier Reed de Alanis. He joined the Department of Chemistry and Biochemistry at University of California at Santa Barbara in 2009 as an assistant professor. He received his bachelor's degree from Fort Lewis College in 1999, where he conducted undergraduate research under the direction of Professor William R. Bartlett. He obtained his PhD in 2006 under the supervision of Professor Tomislav Rovis at Colorado State University, with a research focus on asymmetric catalysis. Javier then moved to California, where he worked in the area of total synthesis with Professor Larry E. Overman at the University of California. Our last author was Feng Peng. He joined the Process Research Department of Merck & Co. Inc. in 2012. His research focuses on using state-of-art organic chemistry to address critical problems in drug development. He received his bachelor's degree from Beijing Normal University. He obtained his master's under the supervision of Professor Dennis Hall at University of Alberta, with a research focus on boron chemistry. Feng then moved to New York City, where he obtained his PhD in the area of total synthesis.